Welcome to a new test and teardown video. This time I got some pretty new and exciting equipment. It's from Associated Research. A HipotUltra III model 7650. So this one will do 5 kilovolts of hypot testing. And then I also got the scanner module. So this is an SC6540 Matrix Scanner. So it's 8 channels, and it will do all sorts of combinations of scanning. So there's an interlink cable between the two units, and this way you can perform more or less like 3D scanning of all sorts of things with different, I don't know, connections, I guess, right? I think first we're gonna play with just the main module and see what this is all about. It is, as you can see, brand new in the box. I had the pleasure of unpacking everything, so this is, yeah, brand new with software, manual, all the cool things, and even got the the cable between the two units. See, it is completely sealed in the back, so nobody unpacked this and used the two modules together. Also got that will be 19-inch rack mounts, and I got all sorts of really cool cables and connectors as well. Those are the high voltage connectors you plug into the high voltage here, and they are really neatly inside the package. And here is a cable. I guess this is the cable that goes from the main unit to the scanner unit. I really like this super soft silicone cable, and it says 30 kilovolts. And look at the distance. I mean, that will handle a lot of kilovolts. And there's a good solid connection, so that is great. And we've got the 2 ground leads for continuity check and the return. And this is, of course, what I need to experiment with. So I think I will remove the scanner first and then power up the main unit and see what's going on here. This is the back side of the unit, and like I said, it is brand new. There's also an output on the back. Look at that. There is some sort of a module plug-in. Let's get some light here. Ooh, what is that? Some completely in the dark. So this is probably some sort of expansion, but it says here about an interlock disable. And of course I looked in the back because I got everything. This unit is completely brand new, like you can see here. Whoopsie doopsie. So here is some testing for mains connector stuff. Also 9-inch rack brackets, some more connections. That will be a ground lead. I think I need that for my first experiment, so that is good. Let's play with that. And I don't know about that one yet, but of course we'll check it out. See, what I found here is the interlock disable, and they put in some secret components in this one, I guess, and then sealed this one. So I guess this is the only place I can put it, right? Interlock disable. Aha. And that will be the scanner cable. I don't know what signal output is doing. Why is this not? Okay, good. So Let's try and power it up and see what happens. And let's... Mains is applied. Oi, oi, oi. 26 watts. What have we got here? I'm sorry, I'm laughing. So what is the difference between yes and okay? We need to call. Okay. So we are ready to play. Still 26 volts. And we are at 100 volts, 10 milliamps. Why are you doing that? Shut up. So I can't do... That will be 40 volts and 0 nothing. I think we need to play a little bit with the test times. I wanted to set this up for like 1000 volts a few seconds, so I can measure with an external voltmeter that is actually doing something. At least that is my first idea. Well, the menu system is actually really easy to figure out. So I kind of hope I got this accents continuity is off, blah 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 blah. So I got a ramp up of 1 second and a 12 of 10, and the ramp down is 1 second. Okay, cool. So I think I should be able to do exit and then I'm back. See, 1000 volts. So I mean, I should be able to hit test now and see the voltage. But why do we see this? So it's ramping up the voltage, and when it sees 0.2 microamps, we kind of stop because there is a problem. I don't understand that because I set it for 10 milliamps. Hey, damn it, it's not that easy to figure this out. Okay, I finally figured out how to work this thing. Haha! It was in the settings. So look what I've done now. This is 1000 volts. I hit set and it ramps up the voltage to 1000 volts. Exactly. And it also measures the current, 0.9 microamps. And there's a clear warning. This one was blinking red. So there's a clear warning. Something bad is happening here. You should, of course, not touch anything. And then it ramped down and turned off everything. The funny thing is, there's, of course, 0 volts left on this unit. But why is the display not going to 0? It kind of is not updating live here. So there's a 0.11 kilovolts. So that is 110 volts. That is a little bit weird. So it's kind of not updating live here. See? Ramping up. Running. And then it's 10 seconds has passed in a second, and then that is weird. More. Exit. Top. Edit. That is my program. Ramp high. I don't understand exactly what ramp high means. Charge low. Arc detector. Continuity. And prompt. What is that? Edit. Ooh. Yabba dabba doo. Exit. Yeah, I think I'll play a little bit more with this and probably get back in a second. here is actually a problem. If you go to the different test types, and you go here and play a little bit with changing the different test types, all the different parameters of the different settings. Of course, this can do AC voltage and DC voltage and whatnot, right? So let's go back to DC voltage, enter. Now, oops, all your settings, they're gone. So you need to input everything again, 1000 volts, how many microamps, enter. You know, everything here is now completely gone. Look at that. Ramp up. I like that to be 1 second. Exit. And so on. Yeah. Meanwhile, I figured out exactly how this ramp up and ramp down kind of thing works. See, that was 2 seconds of ramp down. So all you have to do is give it a little bit more ramp down time, and then the voltmeter will reach a lower voltage when it is down. So there's a little update kind of bug here. See, now it's ramping down, and now it will allow it for a better ramp down because it's not updating after it's stopped the cycle. So here's a pass, so there wasn't any arc over, and that means we can actually start to test some equipment. So that is really, really cool. I think it is not so much more fun to play with this unit, or we need to try and make a little setup if I can arc something over and make it fail and see what happens. So this is what I want to try and see if I can set up something here. So let's just prove if this tester is able to test something that will arc over. This is one of those over voltage protectors. I just connected this to the return and the high voltage line. Yeah, I didn't do it super safe and all that stuff, but I'm a professional. I know I'm not supposed to touch anything here, right? So this one, beep, stop. So there is a short at only 90 volts and the current was more than 10 milliamps. Obviously those will handle kiloamps, but of course in a very, very short period of time. But I mean, this unit is definitely working, and it will ramp up the voltage until there is a current, and it will stop and it will tell you exactly what happened. So I'm super happy the unit works. So before I open and have a little look, I think we should definitely try 5,000 volts. We can hear that. It is making quite a lot of noise. And then it went away. And current consumption, power consumption is now 27 watts in idle. But it went up to 32 watts. And I could really hear something was yelling and screaming inside the unit. So there's a switch mode converter that steps up the voltage. But it generates definitely the correct voltage, and all that is super fine. Try and listen here. Wow, can you hear it? 32 watts, yeah. 4.9 microamps, obviously. And then it ramps down the voltage. There's still this ramp down problem here. I mean, you just need to remember to change the ramp down to a higher, to a longer time. Anyway, I think I've been playing enough with this unit. I definitely want to see what is inside. It is really, really big, and it is very, very heavy. That is weird. Why would this be so heavy? I don't know if you can see this, but I mean, it's just the entire table is the kind of space this takes. Better remember to pull out the power cord, and obviously stuff could be charged in here, so I should be careful. And we are inside. Holy moly. I did not expect it to be that super sexy. I mean, this is top of the line design all the way. So there's a little mains transformer down here running everything. And I mean, it's just full of all sorts of circuit boards doing all sorts of cool things. And another power supply switch mode. And look at that. So this switch mode circuit here is obviously a variable primary side. And then it goes into this step up transformer. Look at that. So here we got the primary windings, and you can definitely see we got thicker windings in here. And then we got the high voltage super windings out here. And they're actually in its own kind of enclosed plastic casing, and then it's fully potted. That is one big, powerful, but of course it can do 10 milliamps at 5,000 volts. So yeah, you need some sort of a power transformer of the good stuff, right? We got some capacitors here that will make it into DC. That will be the rectifier diode, current sensing with proper isolation. Nice stuff. Definitely made the right way. And if I'm not wrong, I would expect us to have a push-pull halfway of our full bridge here, and then the primary side will be a variable DC, and then a fixed frequency chopper or oscillator for the primary side, right? This is a very good and very normal way to make a variable high voltage supply. I've seen this quite a lot of time, and that is almost how they all do that. And look at that massive main board here. What kind of... What's... Oh no. That is the real-time clock, and that is also how it figured out the due date was passed for calibration. We got some flash, RAM, and also some programmable circuits. That's probably the CPU, if I'm not mistaken. Well, I'll see if I can probably get... Oh dear. A Philips. Oh yeah. Okay. What is that? All sorts of opto. Yeah, the entire interface here is opto couplers, right? And then we got all the logic. What is that little add-on interface? We got the scan and remote kind of stuff here as well, and the little beeper. You can plug in some sort of expansion. And what is that? We got even more stuff. Really? There is... What have we got in? Is that a secret room of goodies? Or is that... hang on, what that is? I figured that out. So here in the back, you could remove this. So there's another expansion option here. So this is a smaller scanner as far as I remember, right? So you can put in a scanner here, and it is also connected to the high voltage and some control lines to do, of course, some scanning. So that explains. It is just incredibly heavy duty. Hui. And we also got high voltage out here, yeah. I really love those connectors. They're really, really good. And I mean, high quality, super product, definitely. That'll be all the displays and all the stuff here in the front. There isn't a lot. There isn't really a lot more to see about this. That is kind of what there is to it. Something here gets hot. There is a... Oh, look at that. There's also a temperature protection on that heat sink. We got a... That is a flyback diode. And then there is this capacitor in series with the primary side. So, yeah, I mean, that is a half bridge then. And then we got a relay here for protection and stuff like that. So that's probably what I heard when I cranked up the voltage. The fan went on, right? But I could see current consumption was going up exactly as it was following the voltage output. I mean, that transformer is just really, really nicely made. Look at the windings and all the goodies here. And it's only like one set of diodes, not even a bridge or not a double or anything. No, they mean business here. And this is how they measure the voltage with all those resistors here in series down to the voltage and current measurement amplifiers and goody thingies. I wonder why we got two different current sensors. Oh yeah, I know now what they can do. You know what this is? This is actually relays, right? Because they can, this unit can do AC and DC as well, right? And that is why they have their output directly here from the AC. So that's actually relays. That is cool. AC or DC output and all that kind of stuff. So we will probably be measuring currents in some other fancy way. Oh, that will also be mega ohms. Like you can see, I'm just poking around here with something made of plastic. I'm not completely retarded, because of course this is discharged and completely safe. But anyway, the distance here is not that big. Yeah, that is definitely a beautiful, beautiful unit, and I can't wait to look inside the scanner. How about we do that? Before I open the scanner, I just want to have a little bit better look on how nice and shiny it is. Module A and Module B. So there is some sort of... This is not heavy. Oh yeah, look at that. We got two different modules in here, right? And only one of them is populated. And current and return. So we can measure current. Address. This is our scanner input and output. So I guess this it continues in here, so we can expand with another module. And those super nice high voltage plugs. So it should be fairly easy to open. Yeah, that was super easy. Now we're inside the scanner, and as we can see, only the bottom module is populated. There's a plate here we need to remove so we can access, so we can see that board. See, it's not even mounted like that. It's just one screw to the top, and that will be the controller board down here. This is just a super simple parallel protocol. Got some optocouplers and interface stuff. And this address kind of thing, I don't know, it's probably some 8 bits and 8 bits addresses and stuff like that, right? So you can figure that out. Yeah, tons of capacitors and filters and all that kind of goodies, and then we go to optocouplers to do everything. Ah, yeah, look at that. So here's module A, that is what it says here, and that is probably module B. Yeah, so that is the same unit that will do both of them. And a crystal. Yeah, it's really beautiful. And they put in, that will be all the LEDs, and that is just, okay, that is, so that flat cable for that is, I need to take this plate off. We need to look a little bit more, right? Oh, that is so beautiful. This is how you do it. A 5 kilovolt switcher made from relays. I really would love to see how this relay is designed inside, but that will require me to break it open. So I'm so sorry that is not going to happen, because this unit is brand new and it actually works. So I'm sorry, I can't go any deeper than this. Oh yeah, so that's just the relay driver and the optocouplers on the other side. And here we go, the current output monitoring. Oh, look at all the ferrites here. And that is, of course, when this sparks over, you create quite a lot of high voltage harmonics. So they're filtering power supplies, they're really taking good care of high frequency filtration. Look at all the capacitors and all the inductors and all that kind of stuff, and double isolation, double drivers and all that kind of goodies. This is how you want to do it if you are serious about it. Those connectors are super good. I could really use them for another project, damn it. And again, filter windings and super nice 30 kilovolt silicon cable. Wow. Yeah, but all I can say here is a million times wow. Every time I look at anything in here, it's just absolutely nice. Look at the size of those. Massive. So that is our high voltage input that goes probably to the first. Oh, they even say here how this goes. It's definitely one first enabler, and then we go up and down, and then you can discharge the input here with that. So all those will be discharge relays, and all this will be power or voltage output relays. So that is how it is done for your safety, because you will probably charge something with this. Just a tiny little, amount of picofarad or nanofarad or whatever you're doing at 5,000 volts. I mean, you definitely want to discharge this when you're done with your test. Yeah, I will definitely assemble this beauty again. That was fantastic. Caution. Yeah, you better be. I mean, I can lift this with one hand, so that's all right.